So yesterday we started talking about area and we started talking about tiling. Some of these shapes have been tiled. What does that mean to tile a shape? What does that mean to tile a shape? Mason, what does that mean?
I think it was width and
Interesting. Kylie, what does it mean to tile a shape? This was your homework last night. Explain to me about tiling a shape. Lily, what does it mean to tile a shape? To do what? Asher, what does it mean to tile a shape?
For the first number, you can use it in the column for the length, and then you could use the second number on the top for the row. The tile.
Bria, what does it mean to tile my shape?
Like to almost put boxes inside of the shape, and then you can count them, and the total will be how much area you have, or you could also do multiplication with it too.
Beautiful. When you are tiling a shape, that is when you are creating an array. You're actually using square tiles, Geo, to build a shape. In this case, it looks very much like an array. And just like Bria said, we can count or we can do a shortcut. Chloe, what's our shortcut? A little less time dancing, a little more time paying attention. We could count, but we have learned a shortcut from counting. Gia, what is our shortcut? We can multiply because we know how to solve an array. So we can use the same rules that we have already learned. All right, this question says, which has more area? We have shape A, shape B, and shape C. When you think you know, give me a secret thumb. Tricky. Do you think you know? Then give me a secret thumb. Thanks. All right, if you think shape A has more area, I want you to stand by table 4.
No.
None of you? Okay. If you think shape B has the bigger area, I want you to stand by table 1. No, a couple of you might think shape B. Go for it.
Okay.
Mason, yes or no? No? All right, so all of you think shape C?
Yes.
All right, just for difference of opinion, Bria, why did you say shape B?
Because it's bigger, and it looks like it's wider than the other two shapes.
Okay, so it is definitely wider. Bria, let me ask you this question though. Is how wide something is the only thing involved in area? No, so it looks shorter than my other shapes too. So why do you think shape B has more area?
Because the top and bottom lines look like they are a slight bigger than the other two.
Okay. Do you know how many boxes you think is in shape B? No. Billy, what do you think? I know you're in shape C section. Why do you think shape C is the bigger area?
Because shape A there's only 12 boxes because there's 4 in each row and 3 in each column. That's 3 by 4.
No.
And in shape B there's only 6 squares, but you don't see the line. And in shape C there's 5 in each row and 3 in each column.
So based on, we're assuming that shape B is using the same size tiles,
Yeah.
right? What if shape B was using this size tiles?
Then they would have a lot.
Does that mean my area is any bigger? Even if I measure my tiny closet in inches, that's going to be a lot of inches, versus my big classroom, even if I measure it in feet, that's going to be a smaller number. But does that mean that my classroom is smaller than my closet?
No.
No. So if you ignore my boxes and you pretend that shape B is using the same size boxes, I might argue that shape C is larger.
Yeah.
We don't know because shape B is not tiled and we don't have any dimensions. But if I can use my imagination and put these boxes in here, I don't think it's going to be as large as shape C. I do get what you're saying, Bria, in terms of the width, but you also have to look at how tall, the length, and it's a very short shape, so we don't have a ton of space there. Mason, you can come back, Bria. Thank you for daring to be different.
B and C. Well, B has no tiles.
Yep.
So technically, that whole entire rectangle is actually just one box.
It could be one tile, but again, if this is, Mason, if this is in inches and this is in feet, 1 foot is still going to be bigger than 8 inches, even though the number 8 is bigger than 1 because of the unit. Do you see what I'm saying? Right? Let's just say I go out and I say, oh, I ran 1 mile. Run 1 what? 1 mile? Because that's a really long way. 1 foot? Is 1 foot going to be as big as 1 mile? So you're exactly right, Mason. This could just be 1 tile. However, you have to compare it to the whole shape of C. I still think shape C is going to be slightly larger. All right, so what I would like you to do now is head on back to your seat. We're going to talk about our next little problem. All right, so we have just now learned on the board how to take a area and then go backwards and use what we know about multiplication to try and figure out our dimensions. What's up, Hunter? Yeah, that's fine. All right, so this is our next problem. It's called the bulletin board problem. I want to put up a bulletin board, kind of like the big one that I have in the hall. Please stop making that noise. To display your work, and I want it to have an area of 40 square feet. I haven't decided what dimensions, what size rectangle I want it to be. Your job is going to be to help me figure out different options for my bulletin board. I'm going to give you some graph paper. We're going to pretend each of those little boxes on my graph paper is a 1 square foot by 1 square foot box. Because if I gave you 40 rulers, that would be way too big for you to mess with. So we're gonna do it on graph paper. I want you to draw me 3 different rectangles that have an area of 40. Has to be a rectangle, no crazy tail shapes. Because I can't make a bulletin board that looks like that. Does that make sense? You will need to color each rectangle in and tell me the dimensions and the equation. So, for example, let's pretend I needed a 6-foot bulletin board. I don't, but this is an example. I've colored it in blue. I've wrote 2 square units by 3 square units on the side, and I've written my equation inside. Does this make sense?
Yes.
Okay, but instead of 6 being your area, the area that you're trying to figure out is 40. Lainey, what you need? Nope. Okay, so in your notebook, before I give you your graph paper, I want you to draw a rectangle and put the area of 40, inside. Go ahead and start doing the same strategy we've been working on to figure out what could be your dimensions.